Hello friends, welcome to the Digital Electronics Practicals of FY BSC IT Semester 1. So here we are going to discuss about the basic logic gates and their ICs and how to interface these ICs. So the first practical is about study of logic gates and their ICs and the universal gate. So the logic gates are AND or NOT as they are written here. Amongst that there are some basic gates and then there are some combinational gates. These are the IC numbers that are used for this AND gate, OR gate, etc. So we are going to implement these gates on a breadboard in terms of circuit. So let us first talk about the logic gates.
Logic gates are basically the building blocks of any digital system. They are basically the electronic circuits which have one or more than one input and one output. It is not necessary that they should have one output always. They can have multiple outputs as well. But the relationship between their inputs and output is based on certain logic. And that logic makes the different gates like AND gate, OR gate, NOT gate, etc. These gates are powered up with some voltage value, and that is 0.5 maximum voltage that you can provide to these gates. So the inputs are also given in the form of voltage values. So they are nominal values, like 0 volt is considered as logic 0 or bit 0, and 5 volt is considered as logic 1 or bit 1. Similarly, if they produce the output which is around 0 volt, then that will be considered as logic 0, and if they produce 5 volt or around 5 volt, it will be considered as logic 1 or bit 1. So in general, the output that logic gates give is 1, but in special cases there can be multiple output bits also can be produced by such gates. One thing to note here is that there will always be a time delay between the inputs given and the output produced. So this is how the logic gates can be studied. So now let us talk about the OR gate. The IC used for OR gate is 7432. The OR gate is also called as logical disjunction, which is exactly opposite of OR AND gate. So you see here, for the high output, any one high output will produce the output as 1. So you can see the truth table. So if there are two inputs, so the possible combination with two inputs are 4. So in any of these inputs, if the value 1, that is positive voltage, is present, then it will yield the positive output. For this combination 0 0 only, it will not produce the output, but for all other combinations it will produce 1. So here is the formula for this OR gate. So if we have two inputs like A and B, so the output can be taken as F is equal to A plus B. So this is just a function. You can say it like Y is equal to A plus B or F is equal to A plus B. Both are same. Here is the pin diagram of OR gate, that is IC number 7432. So similarly, like if you are going to hold the notch upside of the IC, the left side pins will be 1, 2, 3 up to 7, and the right side pin will be from 8 to 14. Whereas 7th pin will be the ground pin and 14th pin will be the plus voltage or positive pin. Similarly, as in AND gate, OR gate also have first and second pin as inputs and third pin as outputs. In this IC number 7432, there are such 4 possible OR gates possible. So you can see here 4 and 5 are again input pins and 6 is the output pin. Similarly, 10th and 9th will be the input pins and 8th will be the outputs, and here 13th and 12th will be the inputs and 11th will be the output pin. So we can connect LED to any of this output pin, and we can connect the inputs to this pins. So if I'm going to use only this gate, so here I need to provide inputs at 1 on second pin, that's first and second pin, and the output can be seen in terms of LED glowing or not glowing to show the output whether there is positive 1 or logic 1 or logic 0 can be seen here at pin number 3. So let us see how this OR gate can be implemented on a breadboard.
So let us see how to implement OR gate with IC 7432. So this is the IC for OR gate to implement. So if you are going to hold up this IC with notch upside, these are the 7 pins on the left side and another 7 pins on the right side. This is the first pin, second pin, and so the 7th pin. And here on this side, this is 8th pin, 9th pin, and this 14th pin. This 14th pin is to be connected to the plus VCC, and the 7th pin is to be connected to the ground. So insert this IC into the breadboard like this. Then this is the 9-volt power supply. I'm going to use resistor in between so that I can minimize this 9 volt to somewhere around 5 volt. So this resistor is around 220 ohm. You can use this resistor up to 1 kilo ohm. So to connect this power supply to the breadboard, I will be using this positive side of the power supply to this breadboard like this. Now since this positive supply is of 9 volt, I am using resistor in between in this way. So now my whole positive supply will be here for this somewhere by 5 volt, and this whole line will become negative or ground. So now in this, for OR gate, I require an LED to demonstrate the output or to verify the truth table. So for an LED, the longer leg is the positive side and the shorter leg is the negative side. We can also find it by checking the filament size. Smaller the filament side, the positive side or the longer leg, like this is the positive side, and broader the filament will be the shorter leg and it will be the negative side of the LED. So accordingly I am using this LED. Now I will be connecting this positive to the 14th pin of this LED IC, and 7th pin of the IC will be connected to the ground. Now this IC is connected. Now I am using this two are the inputs, and this color is for the output. So the LED output will be shown on the LED. So LED's positive side should be connected to the output. So here I am using the second gate of this AND gate IC because my first pin is damaged, so I won't be using that. I will be using 4th, 5th and 6th pin, wherein 4th and 5th pin are the input pins and 6th pin is the output. Now let us complete the circuit for this LED by connecting the negative side of the LED to the negative. So right now this LED is glowing because LED has got positive and negative power supply. Now if I am going to give different inputs combination, this LED will glow and not glow according to the truth table. So to this ICs, 4th and 5th I have connected the inputs, 6th is connected to the output here. So for the OR gate, the LED will glow whenever there will be any one input is high. LED will not glow only in case both the inputs are low. So if you are going to make this both inputs to low, the LED will not glow. If any one input of this OR gate is high, the LED will glow. If both the inputs are high, LED will still glow. If we exchange the inputs, LED will still glow. But if both the inputs are low, then only the output will not be shown or LED will not glow. So this is how the OR gate using 7432 IC can be implemented. So this IC 7432 gives you 4 different OR gates So you can use this first three combinations where first and second pin are inputs, third pin is the output, then fourth pin and fifth pin is input, sixth pin as output. And similarly to this side, again this 8th pin is the output and this 9th and 10th pin are the inputs, and accordingly the last one. So this is how the AND gate is to be implemented.